Kia ora Year 12. This video is going to go through a really basic exam pattern on confidence intervals for proportions. So this goes with the second part of chapter 13b. So you can see the question here. We've got a die that's been thrown 100 times, so large sample, and it shows an odd number on 56 throws. We have to calculate an approximate 97% confidence interval for the probability that the die shows an odd number on one throw. So what we're working with here is we're trying to find a confidence interval for a population proportion, and we call that P. But we don't know P, we know P hat. So P hat is our sample proportion. Let's turn that off. Sorry about that. Okay, so P hat is equal to 56 out of 100, which is equal to 0.56. Now, we know that because the central limit theorem kicks in above around 30, that the sample proportion will be roughly normally distributed. On average, it will hit the true value of the population proportion, so the mean is P, and the variance is going to be P times 1 minus P over N. So that means that we can set up a confidence interval for a sample proportion as follows. Right, so this is P, and this is my sample distribution of P hat. We only get to see one draw from that distribution, but we can use this to get a plausible range of values for the population proportion. So we're going to have P hat as the center of the confidence interval, and then we're going to surround it with a margin of error, and that's got two bits. The first bit is my Z value from my normal distribution, right, and that's because of the central limit theorem, so we can assume that P hat is normal. And then I have to times that by the standard error for P hat, which is going to be the square root of P times 1 minus P over N, right? The problem is that we don't know P, and we need to have something to estimate that standard error, so we just substitute in the best that we've got, which is our P hat. So it's pretty straightforward, and I think you get given that formula, but it's pretty easy to remember it once you've done a few. So for this example here, all we need to do now is to find that Z value. We want a 97% confidence interval. So moving back up, we have to go over to our table. Here's my very conveniently plonked in table. I'm looking for, if it's 97%, that means I want 1.5% in each tail. But the way that my table's set up, that means that the number I'm looking for in here is going to be 100 minus 1.5, right? So I'm looking for 0.985. Don't make the mistake of thinking that you're looking for 0.97. You're not, right? So we're looking through our table here, and happily, we have exactly the right answer without any add factors at 2.17. So going back over here, what do we get? Well, we've got 0.56 plus or minus 2.17 times the square root of 0.56 times 0.44 divided by 100. And when you chuck all of that in your calculator, you'll get this. You'll get 0.56 plus or minus 0.1077. You must write your answer as an interval. So the 97% CI goes from, now I would prefer to do it as a percentage, right? So with three significant figures, 45.2% to 66.8%. You could do that as a decimal. I think that's fine either way. All right, thanks for watching. That's about all there is to it. On the live lesson today, I'm going to go through the proof of where the variance of the sample proportion comes from, but this should be good enough to get most of you going on 13b.